Okay, so let's start with a recap, um, a quick small recap. So we started off with the definition of hydrocarbon, and among hydrocarbons, there was a family by the name of alkanes. We defined alkanes first. We went with a few properties or general information about the alkanes. Then there was a chart about physical properties of alkanes, what their state of matter can be, talking about their boiling point, melting point, density, etc. Then we skipped a
सर
page, moved on to G.
तो ये फिजिकल स्टेट्स वाला टेबल हमने याद करना है
Pita, you are supposed to not go with the boiling point, but the rest of the thing, yeah, you're supposed to remember that. But it's easy because once you know how to name them, you know the first two parts. Once you know how the molecular for general formula, you know how to calculate the molecular formula, and probably you already know about physical state because it changes as we go down the series. So there's not much of memorization apart from boiling point, and that you do not need to memorize. Okay, so cutting out the column of boiling point, the rest you may memorize, but you automatically remember that by a few simple rules. Okay, so coming to the next point, we defined that any specific family by the definition of chemistry in organic chemistry is known as homologous series. We defined homologous series then. We went on with the naming of compounds, and skipping a few pages, we came to the naming of organic compounds, that is commonly known as nomenclature. We studied the prefixes and the suffixes important in nomenclature. Then we moved on to the phenomenon of isomerism. What are isomers? How molecular formula can be same, but the structure can be entirely different, along with its different properties, different physical properties. One thing that is yet remaining to be done in case of this family is actually the chemical properties. So to go with chemical properties, we're going to start with this page, page number 256.
तो अल्कीन वाला पार्ट कर लिया हमने
No, beta, no. That is the next family. We're still on alkanes. Okay? So what we are supposed to do is starting from this page number 256, the burning of alkanes, which is the first chemical reaction of alkane. Okay? So if you have no questions, then we can start with for our work for today. Okay, so starting off with burning of alkanes. In case of burning of alkanes, this is a chemical property. Now, as far as you know about burning, not just talking specifically about alkanes, burning anything requires oxygen. It's actually a reaction of oxygen with any material, whatever you're burning. So it's commonly also known as oxidation or an intense reaction with oxygen in the air, which we also studied back in chapter number 4 as oxidation or as burning or sort of reaction with oxygen. Okay? So one chemical property that all alkanes have in common is that they burn exothermically, which means that they are going to give a lot of heat out. Okay? They're going to give out a lot of heat. So exothermically, they make good fuels. Controlling their availability and cost can have great political consequences. When they burn in a good supply of air, the products that are obtained are carbon dioxide and water vapors. Take a look. Methane, which we know by the name of natural gas, or commonly in Pakistan is known by the name of sui gas. Okay? The gas that we use in our homes to cook our food and for other different domestic purposes. Okay? Methane, CH4, is burning in the air with oxygen gas, and it's producing carbon dioxide and water. I hope you're familiar with this reaction already, but in case of IGCSE, this reaction is important when we do it with other alkenes as well. Take a look. Moving on to a bigger alkane, ethane, which has 2 carbon atoms, it reacts with oxygen and takes up actually more number of oxygen molecules to give us more number of carbon dioxide and water molecules. The balancing and the completion of these equations is basically a question in IGCSE. Okay? So what you're going to do right now is that you're going to write me an equation for reaction of propane, okay, C3H8, C3H8 reaction with O2, giving us CO2 and H2O, and you're going to give me a balanced equation right away. Take out a piece of paper and a pen, go ahead with the equation, write the equation, balance the equation, and simply give me the balancing numbers on the chat. Go ahead. I can wait. Take a few minutes. Propane is C3H8, reacting it with O2, producing CO2, carbon dioxide, and H2O, water. Balance the entire equations and give me the numbers in the same order. The number for propane first, then the number for oxygen, then the number of carbon dioxide molecules, and lastly, the number of water molecules. I'm waiting. You may write the numbers in chat. I hope you can see the Word document over here, and what I'm about to tell you is that we are actually taking an alkane, we are reacting it with oxygen, and we are producing, oh, sorry, we are producing an carbon dioxide plus water over here. But there is one way to balance it, and that balancing only goes for this equation the way I'm about to tell you. The mathematical uh, method or the order I'm about to tell you is like this. Every alkane consists of only two kinds of atoms, carbon atoms and hydrogen atoms. So every alkane is made up of carbon and hydrogen atoms, which has a specific general formula for alkanes, for which the formula was CnH2n plus 2, which means number of carbon atoms are supposed to be multiplied by 2, and 2 added to it will give you the number of hydrogen atoms. That when reacted with oxygen, carbon when reacting with oxygen produced carbon dioxide, and hydrogen present in the alkane when reacted with oxygen produced water. Hence the two products of this reaction, carbon dioxide and water. Okay? So what we are going to do over here is that I'm going to tell you a trick that we usually tell to our students in A levels, but this is also going to be working in O levels. That is how to balance this equation. Now, every alkane it consists of two atoms, C and H, right? Let's go for somewhat a bigger font so it's easier for you to read and view. So every alkane consists of carbon and hydrogen atoms. Let's, for the sake of understanding, consider this, and number of carbon atoms as X and number of hydrogen atoms as Y. All right. And to consider the number of oxygen atoms, we'll do that a little later, but let's consider it like this. Okay. What we are going to do is that we are going to produce carbon dioxide from it, the formula for which is CO2. And for CO2, now, if the book is open in front of you, you would see the number of carbon atoms present in the alkane and the balancing number for carbon dioxide is same. Is that so? Take a look at both the reactions in the book. The number of carbon atoms on both sides are balanced. So of course, it's a balanced equation, so that is supposed to be balanced. But what I mean from that is that we can take this X and we may write this X right over here before carbon dioxide, like this. I hope that explains it. And after that, for water, take a look. The number of hydrogen atoms present over here are actually divided by 2, and then that number is considered for water. Okay? So what we are going to do, in order to put a formula for water, We are going to take that Y, we are going to divide it by 2 before we put it for water. Do you get the point? Any questions so far? Do you get the point, class? If you don't get the point, let me know. Because it's purely mathematical, it's not chemistry. All right, I'm happy if you get it. Then coming to oxygen. Okay. What would be the formula for oxygen? Let me tell you, the formula for oxygen would be something in which Y is divided by 4, then X is added to it. Take a look. This completely represents the equations, the 2 or 3 equations that you've gone through, the equation of methane with oxygen, ethane with oxygen, and propane with oxygen. And the formula is very good when it comes to that. Now, using this formula, sometimes you may need to come up with numbers other than whole numbers for these molecular values, for this X and Y written before carbon dioxide and water, that's fine. Or before oxygen, you may use a decimal number in that case. Okay? In order to explain it, let's go with a couple of examples. Let's consider a higher, a bigger alkane. Can anyone suggest an alkane other than methane, propane, and butane? Oh, sorry, methane,
Sir,
ethane, and propane?
hexane.
Hexane. The formula for hexane is the same, student, please.
Sir, C6.
C6, H,
H14.
C6H14. So the formula for this would be C6 plus H14. And of course, now, what you're supposed to do is to not go with oxygen right away. You're supposed to first go with carbon dioxide. And when you're done with carbon dioxide and water, then it would be easier, much easier for you to go with the balancing of oxygen, right? So carbon dioxide here is supposed to be what? The X over here should be the number balancing carbon dioxide. So Rafi, that would be,
Sir, 6.
right, that's very easy. That's 6, okay? And when it comes to water, let me just write the formula for water. And Rafi, what would be the number for water?
7.
7. Why 7? Because this formula says that whatever is the number for hydrogen over here, which is 14 in this case, would be divided by 2 and number would be written over here. So 14 by 2 is equal to 7. For oxygen, we are first supposed to go with the first bracket, that is 14 divided by 4, and then add x to it. What is 14 divided by 4?
Sir,
3.5, right?
3.5.
3.5. That you can do with a calculator. That takes no time. But if you can go with mental maths, that's even better because I'm not using a calculator. That is 3.5. 3.5 plus x. What is x? X was 6.
6.
So that would be
9.5.
9.5. Now, either you can go with the same numbers written over here, or you may convert it into whole numbers. That's completely fine by me. How can you convert the entire equation into whole numbers? By multiplying the whole equation with 2. That is, to write 2 over here, and 2 into 9.5 would be equal to 19, of course. 2 into 6 would be equal to 12, and 2 into 7 would be equal to 40.
40.
Both of these equations are considered correct in case of IGCSE examination, and you get complete credit. Either you go by the first one or you go by the second one. The equation is supposed to be correct. Well, it's not important that you're using whole numbers or decimal values. However, in past, yes, I remember back in C1 and C2, I have asked you to go with the whole numbers. That was a startup, baby steps, of course. And now you can also go with decimal numbers. Is that clear for everyone? Any questions so far? Because this is more mathematical than it is chemical.
No, sir.
Everybody understands? What about girls? Are we clear?
Yes, sir.
Okay, good, good. Do we need to go with any more examples, or it's good enough for you? Okay, that means it's good enough. We do not need to go with any more examples. What I'm going to do is that I'm going to stop. We all understand, as we all understand that we have to balance the equations, and we just did a formula for balancing of alkanes like this. Let's study more about burning of alkanes. Methane forms the major part of natural gas. It's more than 90% of the natural gas is methane that we use in our houses. We use that to cook food. We may use it to produce electricity. We may use it to heat up our homes, whatever the requirement may be. Okay? Propane and butane, however, burn with very hot flames and are sold as liquefied petroleum gas, LPG. Now, LPG is quite common in the usage of cylinders all over the world or even in Pakistan. So I hope you're familiar with LPG. Okay? They're kept as liquids under pressure, but they vaporize easily when that pressure is released. So in area where there is no main supply of natural gas, you may have seen propane tanks in gardens which supply the fuel for heating system. In Pakistan, we commonly use them not just in gardens, but in our kitchens and different other parts of our homes. Okay? Cylinders of butane gas are used in portable gas fires in home. Of course, we do that. Butane is also used in portable camping stoves, blowtorches, and gas lighters. So these paragraphs, basically, you can give them a heading of uses of alkanes. Yeah, uses of first four alkanes, because they are uses of methane, ethane, propane, and butane only. Have been a part of past papers, paper 4 specifically, where they have asked a couple of uses for methane or for propane or for butane. Or they might ask you what LPG stands for and how it is used. Are we clear? Okay. We've already studied homologous series, but before we move on any further, there are some reactions for alkanes that we still need to do. Just a second. Okay. Chemical reactions of alkanes. Alkanes are rather unreactive compounds. We call them inert, we call them unreactive. They're saturated, so they don't take part in any of the addition or other kinds of reactions. They are unaffected by acids and alkalis. However, they can take part in substitution reactions, particularly with halogens. But before we move any further with substitution, let's study the combustion or burning of alkanes. Burning of alkanes is also known as combustion. Okay? When a hydrocarbon burns in a good supply of air or oxygen, the two products, carbon dioxide and water, are produced. The word equation for butane would be something like this. So you have seen the equation of methane and ethane as the previous examples in the book. You have done the balancing of equation for propane and oxygen yourselves. And here comes the equation of butane. So all first four alkanes are here in case of their burning and they're producing the products carbon dioxide and water. So the same products are obtained whichever alkane is burned as long as there is sufficient supply of oxygen. However, if air supply is limited, now this is another case of combustion. If the air supply is limited, then the poisonous gas carbon monoxide can also be formed. Carbon monoxide is the product of incomplete combustion of hydrocarbon. So what you're supposed to write over here is that the first paragraph and the equation is complete combustion of alkane or complete combustion of hydrocarbon. Oh, okay, these are an example of alkanes, so complete combustion of alkanes. You may write the heading on this equation or for the first paragraph, complete combustion. However, for this paragraph, right below the on top of on top of the equation of carbon monoxide, this is incomplete combustion of alkanes. I hope you're writing on the book as per requirement. For incomplete combustion of a hydrocarbon, take a look at the equation. It's not producing carbon dioxide anymore. Instead, it's producing carbon monoxide. right? I hope you're familiar with carbon monoxide. Carbon monoxide is actually a gas which is produced by incomplete combustion when there is limited supply of air, but yet there is burning. Carbon monoxide is toxic because it interferes with the transport of oxygen around our bodies by our red blood cell. I hope you've studied that back in biology. Let me revise and let me clarify a little bit. Every year, a number of people die accidentally from carbon monoxide poisoning because of poorly serviced gas fires in their home. If the flows to the fire are blocked, insufficient air is supplied to the fire and carbon monoxide is produced. Simple carbon monoxide detectors can be bought in supermarkets or electronic detectors fitted in homes. These detectors, the smoke detectors, are actually carbon monoxide alarms. They'll tell you that there is smoke nearby and the air is insufficient. If you're not going to stop that smoke, more and more carbon monoxide would be produced, which would become toxic and may kill you. Something that is not written in the book, and you are supposed to write it over here. Let me write it on the book so that all of you can write it too. Carbon monoxide is toxic because it can form strong bonds with hemoglobin. I hope you are familiar with the word hemoglobin from your biology book. Hemoglobin and does not then allow oxygen to bond with hemoglobin, and hence the person starts feeling first headache, then dizziness, then fatigue, leading to unconsciousness, or maybe death by asphyxiation.
ये लिखना है
Yeah, you're supposed to write it. All of it. This is the exact chemical reason behind it. Now, let me go through that again. Carbon monoxide is toxic because it can form strong bonds with hemoglobin. I hope you're familiar with hemoglobin from your biology book, being a transport protein present inside the red blood cells of our blood. Because of the red color of hemoglobin, the blood cells are red, known commonly as red blood cells, RBCs. Bigger part of blood, the part of blood which carries all nutrients from different parts of body to other different parts of the body. For example, hemoglobin is responsible for carrying oxygen from lungs to the rest of the cells of the body and carrying back carbon dioxide from the rest of the cells of the body back to lungs. Okay. When it forms bonds with hemoglobin, it does not allow oxygen to bond with hemoglobin. And the person breathing in an environment which is filled up with carbon monoxide first feels some headache, then he or she is going to feel dizziness. If he stays in the same environment, he will feel fatigue, which means weakness in body. Then it might lead to unconsciousness, or finally death by asphyxiation. Asphyxiation means death by carbon monoxide poisoning. Death by not having enough oxygen or not being able to breathe enough oxygen. That person may require medical help. So whenever there are fires or smokes, the people actually start coughing and they're not able to breathe properly. And if they're not given any medical help, this might lead to very serious consequences, as stated over here.
सर डिजीनेस का क्या मतलब है
Starting to feel sleepy, not in your complete control. Dizziness is when you don't want to sleep, but you are feeling sleepy. your body tends to go into a resting mode. That is, the brain tries to take more and more oxygen, and for the rest of the body, starts sending messages for the rest of the body to go for a rest, so that more and more oxygen is available for the brain. I hope that is clear for everyone. Completing our last paragraph before the class ends, incomplete combustion can also produce fine particles of carbon itself. These have not even reacted to produce carbon monoxide. It is these fine carbon particles or soot, carbon particles are also known as soot, which glow yellow in the heat of a flame, something like this as given in the diagram. They give a candle flame or the safety flame or Bunsen burner or its characteristic yellow color. Are we clear? So I hope that clarifies the whole use of these carbon monoxide detectors and why we have a yellow color in the flame when there is insufficient supply of air or oxygen for that matter. So any questions before I wind up the class? Have you written at the bottom of this page, page 262, what I asked you to write?
Yes, sir.
Okay,
Yes.
good. Good. Then let's wind up the class. Let me clear that out. Are you done writing? Can I erase it?
Yes,
सर
yes.
वो अगर सर कार्बन मोनोऑक्साइड हीमोग्लोबिन के साथ बॉन्ड कर जाए तो सर उसका क्या कर सकते हैं?
Usually these patients are treated with pressurized oxygen environments so that they can actually come back to their health. Taking them out of carbon monoxide environment would be good. The body automatically starts to recover. If it doesn't, we connect them to oxygen. Okay? Making sure they can recover as soon as possible. Right?
Yes, sir.
Okay, class, take care. Allah Hafiz.
Allah Hafiz.